Hello, 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 hello. Very, 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 very good evening, everyone. Hello. Welcome to the one shot lecture of ICSE class 10th. And today we are going to cover the very first chapter, that is force, work, energy, and power. But the thing is, like, the students are always confused, sir, what to study, what not to study. Don't worry, I will be covering all the topics of this particular chapter. All the topics will be covered. We will be solving numericals, we will be solving conceptual questions. PYQs are also there. Don't worry. So just wait and watch and have a look. What exactly we are going to cover? Hi Sapna, hi Ruby. So we will be covering, first of all, our initial topic, that is called force. Then we have torque or moment of force. Then we will be discussing about uniform circular motion. Then work, energy, power. Then we are having machine, lever, pulley, and combination of pulley. And apart from that, previous year questions. That means everything will be discussed over here. Right, Anshika and everyone? Ready for that? If you are super ready, because I am ready, so let me know. If you are ready, just give me a thumbs up with the heart emojis or anything so that we can start right away. Everyone, the very first thing, if I ask you what force is, what is force? When someone is asking about that question, sir, force, sir, I'm going to, provide force to my friend so that he is going to fall in the, you know, over on the dirt, right? Somewhere on the garbage. That is force. But as per the definition, what force is? That is the question. So the simple definition that we have all studied in our childhood, even I studied in my childhood, that was, sir, the push or pull of an object, that is called force. The push or pull of an object, that is called force. Yes, sir, we know about it. So the force is the push or pull of an object. So if you have ever played this tug of war game, remember, if you have ever played this tug of war game, then you will realize that, yes, sir, they are pulling. Force provided, yes or no? Force provided, yes, yes, sir. So similarly, the other team is also providing some pull. So they are applying, both the teams are applying force. Sir, that we already know. But the thing is, mathematically, how we can explain what force is? That is the question. Right. So in that case, I can even write about force. That is, force is rate of change of momentum. Force can also be written as rate of change of momentum. Okay, sir. That is okay. Or in the other words, I can even write m v by t. V by t, that is the formula of momentum. Formula of momentum, mv divided by time. That can also be, if you look into this, see, velocity by time. Can you tell me, like, what is the formula of velocity by time? Velocity by time, yes or no? What is velocity by time? Anyone in the class, what is velocity by time? Sir, mass into acceleration. Yes or no? Yes. Yes, sir. Mass into acceleration. So ultimately, the formula that we have completed, that is mass into acceleration. In other words, we generally call it as, sir, rate of change of momentum. That can be written as mv by t. Finally, we have got ma. Concept is clear. Even although this chapter is meant for ICSE, even the student from the CBSE board or any other board, if you can be a part of this, if you want to learn, please, you are always welcome. Right? Right? Fine. So the thing is, the force is going to be ma. What will be the unit? Unit. So in that case, I will be saying, sir, unit is going to be, sir, mass unit is kg, acceleration unit is meter per second square. But in short, what we write? Sir, Newton is the unit of force. Newton is the unit of force. Perfect. Perfect. Yes, sir. Now, if I ask you, like, what is the relation between, see, Newton is the SI unit. Newton is the SI unit. The CGS unit is dyne. CGS unit is dyne. So that is going to be how much dyne? Can you please tell me how much dyne it is going to be? Uh, Rao Saab is writing like color. See, I'm going to cover the entire chapter of this ICSE. Fine. So that will be covered in that. Whatever topics you are having, that will be automatically be taken care of. So don't worry, please concentrate and learn this. So when I ask about like what 1 Newton is equal to how many Dian, in that case, that is going to be 10 to the power 5 Dian. This is the relation. This is the relation between SI unit and CGS unit. Is that okay? Is that okay? Now the point is, sir, what are the effects of force? We have seen that push pull, that is okay. Push pull, that is okay. But the point is, sir, what are the effects that we can see over here because of the force? I can see like Rao sir, you can write down your question like in case if you have any doubt, because I am reverting on the point what you have mentioned over here, right? Right? So I don't think there would be any doubt. Correct? Motion. See, this is only for ICSE. Force, work, power, and energy. This is the chapter. In that case, you should go to watch the another lecture of mine. Fine, please. Effects of force. Talking about effects of force, sir. What are the effects of forces? So, in that case, the force can move stationary object and can stop a moving object. Yes, sir. I tried that. Tried that. Yes, sir. So the cycle was moving, sir. I tried to stop my friend. The friend could not move. Friend could not move further. Whereas if I'm going to provide force, if Ronaldo is kicking the stopped ball actually started moving. That is one of the effect. One of the effects. Second, force can change the speed of moving object. Yes, yes. So initially, the ball was moving, and all of a sudden, force provided by the bat. What happened? What happened in that case, bacha? Sir, the ball moved with a very high speed. Even if you are playing badminton, when the racket was, hitting that particular shuttlecock, what happened, sir? It moved with very high speed. Yes, sir. Third, force can change the direction of the object. Yes, sir. We have seen that when Virat Kohli plays a very good cover drive. In that case, yes, sir, the direction of the ball when it was coming straight, the direction of the ball can be seen in the other direction, sir. Right. Next, force can change the shape of an object. Everyone, in the birthday parties, you might have burst the balloons, air balloons, right? The birthday balloons you might have seen. You apply force and doom. Correct, correct. This is what you have seen. So this is going to be these are the effects. These are the effects that we have observed. This lecture is class 10th ICSE. Chapter name is Force, Work, Energy and Power. Okay. Fine. So these are the effects that we have seen. The stopped object can be moved object can be stopped, speed can be changed, direction can be changed, shape can be changed. These are the points that we can see over here. Okay. Now the thing is, when we talk about the types of motion, so there are the types of motion. Yes, I would say yes, there are types of motion that we generally see. What are these? There are two types. First, linear or translatory motion. Linear or translatory motion. Second would be rotatory motion. Linear or translatory motion or linear motion. So, sir, what happens in the translatory motion? The curiosity has to be there. So, it says that if the ball is moving in a straight line, if this ball is moving in a straight line, just like I am moving in a straight line, that is called linear motion or translational motion. Translational motion. So it says when a force acts on a stationary rigid body which is free to move, the body starts moving in a straight line in the direction of force. Yes, sir, we can see that this ball, if I am going to provide force, this ball will start moving in this direction. This is the direction of motion. One of the motion. One of the motion. Fine, sir. Rotational motion. What is rotational motion? Rotational motion. Simple example. Fan. Fan. We have seen a fan. So what happens in that case, sir? It rotates. It rotates. There is a stand over there, and the fan is rotating. Zoop, 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 zoop. Yes or no? Yes or no? We have seen that, na? Yes, sir. Sir, what are the other examples of rotational motion? Are see, uh, there is a gate. There is a gate of the room, correct? So that is provided with a hinge, right? So how you are using it, sir? It opens like that. It opens like that. If I'm going to take out, what is going to be happen? There will be an axle, and that is going to rotate. Doom, doom, zoom, zoom. Have you realized rotational motion? Sir, the wheels are moving, rotational motion. See, these are the examples of rotational motion. Amritansh, clear? Clear? Fine. So these are the examples. Please take care that you are having in your mind. So what it says, if a body is pivoted, we are going to look into the certain points over here, and that is called, they are saying pivoted. Sir, what is pivoted mean? Pivoted mean, so if you have realized that, if there is a wheel that is provided with, something, or the nut bolts, mm, tightly packed, pivotation. Fan that is stand through which the blades are moving, blades are moving, that is called rotational motion. That is called rotational motion. This is what, so that point is called pivot point. That point is called pivot point. So it says that the force is applied on the body at a suitable point. So what happened exactly? See, when I was a small kid, na, so I have observed many times. So there were few kids even in my colony. So they used to carry one tire, and they are having one stick. They are providing force and running along with the tire. Have you ever seen someone who is doing the same? In that case, the tire is moving or revolving, moving, circular motion, or the rotational motion is actually going on. So when the force is provided from one side, the rotation is going on like that. That is called rotational motion. Rotational motion. So about the axis passing through the pivoted point, this is the turning effect of the force, and the motion of the body is called rotational motion. Motion of that body is called rotational motion. Answer is quite simple. Fan, gate, these are the examples. If you have ever seen someone, are that salsa dancers, have you seen? So the dancer provides a finger to the another dancer, and they are revolving around that particular finger, right? Rotational motion. Rotational motion. Fine. So this is how it seems. Now the thing is, talking about the types of motion. So we discussed about two things, that is linear or translational motion, talking about rotational motion. But someone, if in the examination, if someone is going to ask, sir, what will be the difference in linear motion, translational motion, then what should I write? Maybe they are going to ask that. Correct? Correct? Then in that case, you would be writing point number 1 over here. Point number 1 over here. When object move in straight line, when object or body move in straight line, move in straight line. Whereas in the rotational motion, you are going to write when object rotate about its axis, like our earth. Like our earth, it is having particular axis, and the earth is revolving around its own axis. Rotational motion. Got it? Fine, sir. Talking about moment of force, that is a quite interesting topic. This is quite an interesting topic. What is the moment of force? This is also known as a torque. This is also known as torque. Torque. Okay, sir. So what exactly it is doing? Let me give you an example, and we will be also doing one of the numerical based on that. So if I tell you by giving you that example, that I think this is going to be so clear. So there is a gate, there is a door or gate, whatever you like to say. This is knob. These are the hinges through which it is mounted or fixed on a particular wall. Correct? Correct? Now the door is fixed. What you can do? You can open the door, you can close the door. Fine. Quite simple to understand. You can open the door, you can close the door, you can pull it, you can push it. My point is, see, if you are providing force, so what sort of force you are giving or you are providing on the gate? What kind of force it is? Sir, this kind of force will be applying so that the gate is going to be closed. Sir, I will be applying this force, the coming out force, the gate will be opened. Yes or no? Force provided inside, force taken out. This is going to be the force or the force application, how you are going to apply force to open the gate. Yes, sir. And this is the distance. This is the distance from the fixed position. I am naming it as R. I am naming it as R. R is the perpendicular distance. So force provided in this direction and this is the distance. If this is the force provided, this is the distance. They are perpendicular to each other. They are perpendicular to each other. So in case if I need to draw the diagram, it will be like force provided in this direction and this is the distance. So this is force applied, this is the distance and they are perpendicular to each other. So whenever I see, when I need to talk about torque, that is going to be force multiplied by perpendicular distance. In short, I can write torque. The representation is tau. Representation will be tau. So tau equal to force multiplied by perpendicular force. This is going to be the formula of moment of force or torque. As simple as that. That is going to be the formula. Now, based on that, can you tell me like what will be the unit of this? What will be the unit of torque? In that case, what I should write? Sir, unit will be, see, the unit of force is Newton. Newton, sir. Unit of distance, sir, meter. That is going to be torque. Force multiplied by perpendicular distance or distance multiplied by perpendicular force. Anything you can consider. That is called moment of force. Unit is going to be Newton meter. This is how you represent torque. I hope the definition or the basic information about the torque is so clear to everyone. Now my point is, what are the factors affecting? What are the factors affecting turning of a body? When a body takes turn, what are these factors? So there are two major factors that we need to take care. Param, clear? Amritansh, clear? Yes. So it says the turning effect of a body by a force depends on the following two factors, and these are magnitude of force applied. Magnitude of force applied. I gave you the example of the door. Na? Remember, if you are going to apply a slow force, the door will be like. But what if you are in anger and going to apply more amount of force? Dad! Why? Because you applied more force. Initially, on a regular days when you were happy, you were providing a small amount of force. As a result, the door was closing slowly. Moment of force was also comparatively, value-wise, it was low. Second, the distance of line of action of the force from the axis of rotation. Second point, from where you are applying the force, which means, I meant to say that if I am going to provide force not from here, from this point, I'm going to reduce the value of R. It would be difficult to open the door. Generally, when we see a door, the knob is always provided at this end. Na? Why not over here? Why not closer to the hinges? The reason is quite simple, bacha. Because we are actually required this distance R as a greater value. Even if you see, moment of force is directly proportional to the perpendicular distance. Clear? Clear? So always remember that we are not going to place the knob or the value of R should be greater to provide more moment of force in a shorter term. Correct? Correct? Now, these are the 2 points that you need to Take care. Next thing is factors affecting turning the body, where we have seen different examples in even in the daily life. Yes, sir, I have seen that wrench. This is the wrench. This is known as wrench. So what exactly it is doing? Sir, we cannot fix the nut very easily. So we have this wrench. So what we do? Sir, we fix it along with the shape and we try to move it. And we can fix it, or easily we can tighten the nut, or we can lose the nut very easily. The reason is quite simple. The force that you are providing, that is in this direction. Correct? Correct. And this much is the distance that you are having. That means force and distance. That means the value of moment of force, that is going to be higher, and the nut can be easily be tightened or loosened. No problem. Anything. Similarly, if I am going to apply force over there, so that holds the nut, and when the force is applied, this is the axis, force is applied. So what is going to be happen? Either it is going to be tight or it is going to be loose, depending on the application that is required for that particular part. Fine, this can be done. These are the few basic examples that explains the value of torque, and we know that there are certain distances that is required, and perpendicular force, or force with a perpendicular distance. Fine. Now the thing is, there are two kinds of thing that we have noticed over here. That is, if anything that you are providing, either it is going to move clockwise or anti-clockwise. If you are providing a force to rotate someone, then one of the side is going to be anti-clockwise, the other side is going to be clockwise. Quite simple. In that case, please remember that if the effect on the body is to turn it anti-clockwise, what exactly it is saying? If the effect of the body is to turn it anti-clockwise, the moment of force is called the anti-clockwise moment. But it will be taken as positive. It will be taken as positive. That means when moment of force is moving anti-clockwise, we will be considering value as positive. Sir, in that case, if the moment of force is going to be clockwise, then what is going to be happen? You tell me. What will happen? The value is going to be negative. Value is going to be negative. Okay. Why, sir? Why is it like that? Like one value is positive, other value is negative. What is the reason? Arey bacha, it is a vector quantity. It is a vector quantity, because again and again we are discussing about force and perpendicular distance. Force and perpendicular distance. So we are talking about specifically direction. So as per direction, for the anti-clockwise movement, the value will be taken as positive. For clockwise, we will be taking negative. So that it will be quite easy for us to understand. If we see torque is equal to negative some value. Got it? Got it? Yes, sir. Torque value will be negative if the motion is clockwise. Fine. Perfect. Next thing is couple. So we have seen like many things in our daily life. The examples are right in front of you. Opening a tap, opening a cap, steering wheel, lock and key. So in that case, what we have observed? We observed that set two amount of force is actually working. Like for an example, even if I need to rotate this pen, then what I have to do? Sir, you will apply one force over here, the other force is moving in the opposite direction. So the one force is moving in this direction, the other one is moving in the opposite direction. Can I apply the different forces in that case? Can I apply different forces, like some different value over here, some other value over here? Is it possible? No. No, it is not going to be happen. See, whatever amount of force that I need to apply, the same amount of force that will be applicable in that case. Is that clear? Same amount of force. Done? Done. So it will be offering equal and opposite forces. What exactly they are offering? Equal and opposite forces. Okay, sir. So what it says? Two equal and opposite Parallel forces not acting along the same line, not acting along the same line, form a couple. This is why they are known as couple. Is that clear? Very good. A couple is always needed to produce a rotation. That means if you want to rotate something, then in that case, it would be highly required that you are providing force in couple. Like for example, um, chakri. Have you ever heard about chakri? So that consists of that kind of structure, this kind of structure, and there is a stick at the top. Remember, that rotates. So in that manner, if I'm going to hold it, if I'm going to revolve, I need to provide the equal and opposite forces. Couple, it starts to rotate. Correct. It starts to rotate along the axis. Yes, sir, we have seen it. Let two. This is what we call it as. This is what you call it as. These are the examples, and this is why the couples are always provided in pair, but equal and opposite parallel forces. This is what couple is. Examples are right in front of you, which I gave you. Correct? Next thing is, now there are some questions based on that. You need to answer this like what would be the answer. The very first question, that is, moment of force is given by. Very favorite question of all the teachers. Like, moment of force is given by. Answer is force times parallel distance between the axis of rotation. Second question, force multiplied by perpendicular distance, torque multiplied by perpendicular distance, and none of these. Remember what I told you? Remember, yes or no? Yes, sir. Sir, there was a formula, moment of force, that is force multiplied by perpendicular distance. Or it can also be written as distance multiplied by perpendicular force. There is no problem. If someone is going to tell you like you can write only in that manner, not in this way, that is going to be highly incorrect. You can write either ways. Both formulas are absolutely correct. No problem. Force into perpendicular distance, or distance into perpendicular force. No matter. So force into perpendicular distance. According to this, the answer has to be B. Agree or not? Answer has to be option number B. Are you also getting the same? Yes, sir. Force into perpendicular distance. No problem. Next question. A door lock. I gave you the example. Na? This is how it seems. A door lock is opened by turning the lever of length 0.2 meter. If the moment of force is 1 Newton meter, then the minimum force required. How to solve? Okay, fine. We'll do all together. We'll do together. Fine. So what is being given? Sir, R distance is given, that is 0.2 meter. Sir, moment is given, that is 1 Newton meter. What we need to find? Force. I think the values are already given, and that is going to be quite easy for you to solve. Yes or no? Yes, sir. So formula is, sir, force multiply R, torque is 1, force is unknown to us, value of R is 0.2. So value of force is 1 by 0.2, that is coming out as 5 Newton. Are you also getting the same value? That is option number A. Option number A is the answer. 5 Newton. As simple as that. Done. Clear? Clear? Sir, more questions. Look at one more. A moment of couple has a tendency to rotate a body in a anti-clockwise direction. Anti-clockwise, remember? Then the moment of couple is taken as anti-clockwise. Clockwise was negative. Anti-clockwise will be, sir, mentality is positive. Answer is negative. Mentality is positive, but answer is negative. Why? Because in clockwise, answer was positive. But over here for the anti-clockwise, it is going to be negative. Perfect. Next, clockwise movements are considered. Clockwise movement. Clockwise movement. Okay, so for the previous one, it has to be positive. Now, for anti-clockwise, it is. For clockwise, it is going to be negative. Sorry, my bad. So for the previous question, for the anti-clockwise, it will be positive. For clockwise, it will be negative. Right. Confusing, na? Right. Right. Fine. Now there is one more question that we need to understand. it's a subjective kind of numerical. A body is pivoted at a point. Okay. A force of 10 Newton is applied at a distance of 30 centimeter from the pivot. Calculate the moment of force about a point. Okay. So, how to solve? How to solve? First of all, given values are required. First of all, given values are required. So, the force is given 10 Newton. 10 Newton. Distance is given how much? 30 centimeter, and we need to find the value of moment. What will be the first requirement? What will be the first requirement? The first requirement is to convert the unit. Convert the unit from centimeter to meter. Okay, sir. So that is going to be 0.3 meter. Correct? From centimeter to meter, divide by 100, that is going to be 0.3 meter. Now, apply formula. Apply formula. So, what is the formula that we are going to use? Sir, moment of force, that is force multiplied by distance, that is going to be 10 multiply 0.3. Torque is coming out as 3 Newton meter. Please let me know if you are also getting the same value. Yes. Are you also getting the same value? Everyone? Cool. Now, we have another question. It says, the moment of force of 5 Newton. What has been given to us? Moment of force of 5 Newton about a point 2 Newton meter. So, force is given to us. Torque is given to us. Calculate the distance of the point of application of the force. That means R is required. R is required. Let's write down the given value. So, force is given 5 Newton. Moment given 2 Newton meter, and the value of R is unknown. Please put the value, get the answer. So that is going to be F multiply R. This is 2. Value of F is 5. Multiply R. R is going to be 2 divided by 5. How much it is coming out as? How much? Sir, 0.4 meter or 40 centimeter. So the value of R is coming out as in centimeters. 40 centimeter will be the value. Tuck, tuck, tuck. Option number C is correct. Option number C is correct. Right? This is how we can solve the questions related to the moment. Next is, a mechanical can open a nut by applying a force of 150 Newton while using a lever of handle of length 40 centimeter. So what exactly, how much is the length they are going to use? 40 centimeter. They are asking another question into that. How long handle is required if we want to open it by applying a force of 50 Newton? Now the question is given in such a way, that force is applied, 150 Newton given, but perpendicular distance given as 40 centimeter. Now they are asking, if the force given is 50 Newton instead of 150, what should be the distance? In that case, that would be required to open the gate. This has been to open a nut, in fact. So this has been asked in the question. No problem. Question is quite simple. Even in that case, what we are going to do, the force given, that is 150 Newton, force 1. Second, the first distance that is given as 40 centimeter. Can I write it as 0.4 meter? Would you mind it? Would you mind if I'm going to write this? No, sir. F2. F2 is how much? Sir, 50 Newton it has to be. And R2. Sir, this is unknown to us and this is what been asked in the question. Yes, this is what been asked. Correct? Okay, let's start solving. Please, first of all, if you want to give it a try, please let me know what exact answer you are getting out of this. I want to hear it from everyone. Please make sure they are asking, he wants to open by applying a force of this. That means the torque value is going to be same. Torque value will remain same in that case. So how we can proceed with this question? How we can proceed with this question? Simple. Simple, don't worry. See, the first torque that we are going to find, that is going to be, sir, F1 times R1. Value of force that is coming out as 150. Multiply distance is coming out as a 0.4. Then that is going to be 60 Newton meter. If I'm not wrong, please tell me if the multiplication is correct. 15 into 4 times, that is going to be 60 Newton meter. Talking about the second one, sir, F2 multiply R2. Moment we have already calculated, yes sir, 60. They're asking how long will be the handle, and force given is 50 multiply by R2. So R2 equal to 60 by 50. On cancelling, how much we are going to get? 60 by 56 by 5. That is 1.2 meters. 1.2 meters. And in that case, the answer is coming out as D. Sir, 1.2 meters will be the value. Apex, like unfortunately, like you got B, but answer would be 1.2 meters. That will be the correct answer. From the next question, I will be giving you polls. You can also give it a try. But before that, we need to understand what equilibrium is. What is an equilibrium? See, it's, yes, option D. When we talk about equilibrium, I always give that example when we are watching like web series or any movie. And it is a courtroom drama. So there is a statue which is standing with a beam balanced beam. So this, how it exactly look like? Sir, it look like something like that. Something like that. Almost like that. Correct. Correct. This is how it look like. Yes, sir. There will be two, you know, bases. We can say there will be two sides where the objects can be kept, and from here it can be hold. It can hold it. We can hold it from here. But the equilibrium says if both sides are balanced, both sides are balanced. Like in that case, how to understand this? Sir, I went to the market and I want to buy tomatoes, and the shopkeeper kept one weight on the one side, like some weight on the one of the end, 2 kg weight, and you want to buy apples. Okay, so there are apples. For example, the apples are capped over here, bunch of apples. So what will happen initially? There are two conditions. Either the number of apples will be more, so it is going to come down. Yes, sir. But if the apples are less, sir, weight will be coming down. So how we are going to balance? Sir, we check that. If this is going to be in a balanced condition, straight balanced condition, neither this is going down or up, even the same for the other side. In that case, we call it as equilibrium. When there is no motion, when no one is moving up or down, or in the clockwise motion or anti-clockwise motion, bacha, then we call it as equilibrium. As per the definition, it says when a number of forces acting on a body produces no change in its state of rest or of linear or rotational motion, the body is said to be in equilibrium. Body should not go anywhere. It should be in a balanced condition. See, in this example, in this particular example, that was the perfect beam balance where the holding part was in the middle. There are chances where this handle will be shifted somewhere else. In that case, how to solve, or if you have that curiosity, then I would be explaining the concept regarding this. Before that, I need to tell you, when we talking about the types of equilibrium, in the equilibrium, even there are types. Static equilibrium. We have another type, that is dynamic equilibrium. Static equilibrium says when a body remains in a state of rest under the influence of several forces. Sir, several forces, but still the body is in the rest. How? Let me show you. The body is capped over here on a surface. On a particular surface, it was capped. Now, what will happen in that case? What will happen in that case? Sir, forces are applied, sir. It is saying multiple forces are applied. Okay, no problem. Multiple forces given. Considering F1, F2, not moving. Not moving. Static equilibrium. It is not going to move anywhere. So, when it says when the body remains in the state of rest under the influence of several forces, the body is in static equilibrium. That means initially it was at rest, still it is at rest. Fine. Still it is at rest. Fine, sir. Dynamic equilibrium says when the body remains in the state of motion under the influence of several forces, the body is in dynamic equilibrium. The body is in dynamic equilibrium. By giving you an example, let me tell you. If there are water droplets, this rainy season is going on, right? The water droplets are coming down. So I'm just considering one of the water droplet. Correct? How many forces are going to act? How many forces are going to act? Sir, the weight is going to act downward. Weight of the water droplet. Weight of the water droplet. What else? Sir, there will be an upward force. Air resistance. What we call it as air resistance. So there are two different forces that we can see over here. One, weight of this drop, and air resistance in the upward direction. Still the drop is coming. Still the drop is coming down. That is called dynamic. So in the static, when the object was kept at a same position at rest, several forces applied, not moving. Static equilibrium. Dynamic equilibrium, when by consuming this example, if the raindrop is falling, weight applied in the downward direction, air resistance, it is still moving. Dynamic equilibrium, not changing speed, it is falling with the same acceleration. So that is called dynamic equilibrium. Fine, sir. Talking about the condition, what are the condition? It says the resultant of all forces acting on the body should be equal to 0. What kind of resultant it has to be? Sir, it has to be the resultant of all the forces should be 0. How is even this possible? Even that is how it can be possible. Think about that. Sir, how is it possible? See, actually what happens when there is an equilibrium, the moment is one side is going anti-clockwise, other side is going clockwise. So the moments are plus or minus. That we already understood. This is the condition that we are going to use. Second, the algebraic sum of the moment of forces acting on the body about a point of rotation should be 0. Ultimately, they are also giving us the same value. So, ultimately, the note point or the bottom line. Dil tham ke baithiye. Bottom line, sum of anti-clockwise moments is equal to sum of clockwise moments. Please take care of that. That is going to be important. This is important. This is important. What? Sum of anti-clockwise moment will be equal to sum of anti-clockwise moments. By solving some questions, we would be able to understand this. For now, we need to understand what center of gravity is. Center of gravity. So much of question not been asked even in the board examination, but yes, there is a concept that we need to understand. Center of gravity. First thing, it will not always be at the center of the object. Not always. For example, if I see this object, the center of gravity may be lying not exactly at the center, maybe at some other point. Maybe at some other point for this pen. Look at this. This is balanced. But the distance from the tip to the finger or from the back portion to the finger, that is going to be different. Getting? So, center of gravity, according to the definition, it says it is the point about which the algebraic sum of moment of weights of all the particle constituent is that is going to be 0. That means it is neither going anywhere. In that case, question has to be there. Question has to be there. है ना? So what kind of question it has to be? Sir, what if the shape of the body is different? Interesting question. No? Sir, that was symmetric. But what if the body is like of the different shape? In that case, what will be the center of gravity? Bacha, to understand this, what we do generally, we try to find out the weight at every point. Weight of the object at every point. Like that. Like that. So I'm going to name it as W1, weight 2, weight 3, weight 4, weight 5, n number of times. N number of particles would be there. This is how I would be trying to find the value of the weights at the different points. And by using this, I would be able to conclude the final point that would be my center of gravity. Finally, that would be the value of center of gravity. So the entire weight of the body can be considered to act at this point. However, the body is placed, no matter how you are placing the body. Sir, how you concluded that the center of gravity is lying at this point? This question has to come into our mind. So what I did, I just took the average. What is the method? Method is took the average of all weights, average of all weights being taken. This is how we would be able to find the center of gravity. Okay. There's a note point. It says the position of the center of gravity of a body of given mass depends on its shape. Center of gravity depending on what? Shape. Fine, sir. It is not necessary that the center of gravity always within the material of the body. Within the material. That means if the center of the gravity of this body is lying inside or at the surface of the body, it is not at all compulsion. Maybe the center of gravity is lying outside the body. Examples I will show you, don't worry. Third, the body of weight W can be considered as a point particle of weight W at its center of gravity. If I consider any object as a point object, then the center of gravity will be also be considered as a point. That is the easiest way to find those values. So please take care of at least these 2 points. There are some fixed values of the center of gravity for the various shapes that you need to remember. Fine, where it is lying. Like for a uniform rod, simple pipe, where the center of gravity will lie, bacha? Center of gravity will lie at the midpoint of the rod. Midpoint. Yes, sir, I can balance midpoint. Second, talking about circular disc. So, circular disc, this kind of disc, flat, that is geometric center. The center of gravity will lie at the geometric center. Fine. The third one, solid or hollow sphere. So if there is a sphere, not given in this, if there is a sphere, globe like, so the geometric center of the sphere will be the center of gravity. Okay. Hollow cylinder, it will be the midpoint of the axis of cylinder. Midpoint of the axis of cylinder. This point. Inside. This point will be the center of gravity. Similarly, solid cone. In a solid cone, it is going to be at a height h by 4 from the base. From the base. If it is a solid cone is not given over here as a diagram, but it will be from the base, h by 4 from the base. Similarly, for the hollow cone, it is going to be h by 3 from the base. So, if there is a cone given to us, total height is h, it will be at h by 3 height from the base for the hollow cone. Similarly, for circular ring, it will be at the center of the ring. Triangular lamina or scalene triangle, the point of intersection of the mediums. And the last one, parallelogram, rectangular, lamina, square or rhombus, the point of intersection of all the diagonals. So these are the some common points or the common center of gravity. This is how you can find out. These questions being asked directly even in the examination. We have observed that they are going to provide you the value, the height of the cone, 20 centimeter. And they will be asking about solid cone, where the center of gravity will be lying for the solid cone. How to do that? So 20 h by 4 from the base for solid cone. 20 by 4, answer is 5 centimeter. Center of gravity will be lying at 5 centimeter. This is how you would be able to solve it. So these are the diagrams. Next is uniform circular motion. Another topic that is related to this, that is uniform circular motion. What is uniform circular motion? Uniform circular motion, to understand, if you have ever watched Lagan movie, there was a character called Goli. So he used to move, the rope with a stone. Zup, 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 gone. This kind of motion is called circular motion. Or any other example. Yes, sir. When the athletes are running on a circular track, that comes under the category of circular motion. So when a particle moves with a constant speed in a circular path, this motion is called uniform circular motion. This is going to be happen. There will be a center, correct? In that case, sir, there has to be some radius as well. You can write it as capital R or small r, depending on you. But here I am considering the radius of the circular motion, that is R. Examples. First example, satellite revolving around the earth. Yes, sir, we have observed that. Second example, blades of a ceiling fan. Circular motion. Stone tied to a string and rotated. Zup, zup, zup. Hands of a clock and a merry-go-round. So hands of clock, that is moving in circular path, and merry-go-round. These are the examples of uniform circular motion. Okay, sir? Clear, sir? Next is, in a uniform circular motion, there are certain points that we need to remember. First of all, speed remains constant. When we are talking about uniform circular motion, the speed will remain constant. That means if in a circular motion, this is quite important factor, please try to understand this. If body is moving with a speed of 3 meter per second, then at every point the speed is going to be 3 meter per second. This is why it is a uniform circular motion, na? So speed is going to be constant. Second, velocity changes continuously. Now the students are actually getting confused over here. So 3 meter second and 3 meter per second. 3 meter per second and 3 meter per second, both the end, how velocity is changing? This is also constant. So my answer would be, bacha, over here, 3 meter per second, magnitude is not changing. That is 3 meter per second. This is not changing. But at every point, direction is keep on changing. Every point. Either you analyze at this point, this point, this point, this point, this point. At every single point, the direction is keep on changing. As a result, velocity, considered as velocity, changes continuously. And because the velocity is changing, acceleration will be there. But the most amazing and important factor is how acceleration is actually changing, or where the acceleration is actually acting. That would be the more important factor. That is most important factor. So to understand this, let me tell you something. If I need to find the direction of the velocity, that is going to be the tangential direction. The direction is going to be tangential direction. And there will be an acceleration that is going to act towards the center, always towards the center. That is called centripetal acceleration. This is what we are going to study, centripetal acceleration. So centripetal acceleration is due to continuous change in velocity. This acceleration is acting towards the center of that circular path. So that is called centripetal acceleration. And amazing part is when we are talking about centripetal acceleration, it will be written as v square by r. That means the square of the velocity, that is provided, and radius. This will be the value of centripetal acceleration. Whereas when we talk about centripetal force, now master of uh, uniform circular motion, like what is centripetal force? So motion in a circular path is possible only under the influence of one force, that is called centripetal force. What does that mean? What does that mean? Arey bacha, what happens when there is an acceleration provided at the center? That means force provided. Arey, you are providing force na, to make it move in a circular path. That is called centripetal force. In that case, this will be represented by, sir, how we can represent? This will be bacha represented by centripetal force, that is equal to mass into acceleration. But which acceleration? Which acceleration? Sir, centripetal acceleration. But I already told you the value of centripetal acceleration. How I can write this? Centripetal acceleration m v square by r. So the formula for the centripetal acceleration is coming out as mv square by r. mv square by r will be the formula for centripetal force. Okay, sir, no problem. But sir, sometime what happens? When I was sitting in the car and my father took a turn towards towards left or right. So let's consider one direction. Consider only one direction. So father took a turn towards left. We were sitting in the car, but we felt that we are moving outside on the opposite direction. Although the turn took towards the left, but what I felt that I was trying to move out from the right hand side window. Why? Why? There is one more force over here that is going to act, that is called centrifugal force. Which force it is? Centrifugal force. So there is one interesting fact about centrifugal force, that is it is always opposite to the centripetal force. Always opposite to the centripetal force. Sir, then what is the difference between centripetal and centrifugal? Both are moving in a circular path. Then what is the difference between centripetal and centrifugal? The answer is quite simple. When you see someone moving in a circular path, okay, I'm looking at a circular path. The athletes are running. On a circular track. Very easy to observe. You are observing. Or the car is moving on a circular track. You are observing. Centripetal force. What you see that, sir, centripetal force is going on and death well, maut ka kuwa. This is what it looked like. But when you were part of the car, this is the difference. When you were the part of the car, that means you were sitting in the car. Father took turn towards left. You felt like, oh, this is what happens now. This is what happens. That is called centrifugal force. So in that case, so a force acting on a body away from the center, that is called centrifugal force. Which force it will be? Centrifugal force. Centrifugal force. But the major point over here that I need to write, what are the major points? The major point is point number one. Point number one. It is always acting opposite to the always acting opposite. Fine. Opposite to what? Opposite to centripetal force. Okay, sir. Second point, it is not a real force. It is not a real force, also known as pseudo force. Always remember that. It is also known as pseudo force. Fine, sir. Now, there are some questions that I would like to discuss with you, that is in terms of true or false. Would you like to answer this? Would you like to answer true or false? The very first question right in front of you, is the velocity of a stone uniform or variable? True or false? True or false? Velocity of a stone uniform? No, sir. Speed is uniform. Velocities keep on changing. So if they are asking, is the velocity of a stone uniform or variable? Then I would say it will be variable. Variable. Is the acceleration of a stone uniform or variable? Sir, it is going to be variable. Avoid that. Avoid that for now. This. Yes. Is the acceleration of the stone constant or uniform or variable? I would say it would be variable because velocities keep on changing. What is the direction of acceleration of a stone at any instant? What is the direction of acceleration of the object at any instant? I already gave you the idea. If you are going to release, if you are going to release any circular object, that is going to move tangentially. That is going to move tangentially. So the answer over here that is coming out as, so tangentially. Tangential direction. Tangential direction. What next? Name the force and its direction which acts on the hand. Hand of clock. Clock. Name the force and its direction. So that will be circular motion. That is going to be circular motion. Circular motion. Fine. Talking about work done. What work done is? This is the second segment of this chapter where we will be learning about work, energy and power. So in this, what is work done? So when we talk about work done is something what you are doing. Sir, but sir, I am sleeping. Where is work done? So in that case, try to understand the concept. There are two scenarios that we can see. So there is one boy, he's actually trying to pushing the wall from both the ends through by using leg and hand. Correct? Somebody tell him that there is no purpose of doing that. There is no purpose. The wall is not going to shift. Whereas this person is trying to pushing the car. There are chances the car will be, moving forward. There are good chances, na? Maybe the car is going to move forward. In that case, when we talk about work done, that is quite simple. When you are applying a force on any body, and if there is a displacement, ah, here, what sort of displacement you would be see? Sir, there is a no displacement. No displacement. Here, there will be displacement, not equal to 0. So what we say? Bacha, if force is applied and displacement is done, it is said to be work done. It is said to be work done. So if the force applied on an object and there is a displacement, then it is said to be work done. Okay, sir. So the work done is said to be done. And in that case, if I need to write the details about work, that is going to be work is equal to force into displacement. Force into displacement. Force multiplied by displacement. Or it can also be written as F dot S or Fs cos theta. Fs cos theta. Why? Why? Why is it Fs cos theta? Good evening, Akhand. Why Fs cos theta? Bacha, the reason is because it is a dot product of two vector quantities. Dot product of two vector quantities, and that is going to be a scalar quantity. That is going to be a scalar quantity. This is what work done is. Clear? Okay, sir. No problem. Now the thing is, work done measurement. So if a force act on a body, the body does not move, the displacement is zero, then no work is done. If there is no displacement, then work done will be also be zero. Yes, sir. What is the problem in that? So my point over here is, my point is quite simple. If displacement is going to be zero, work done is going to be zero. If force is going to be zero, then definitely there will not be any work done. So these are the two scenarios that we need to take care of. First. Second, what will be the unit of work done? Sir, unit is going to be joule. Unit is going to be joules represented by capital J. This will be the SI unit. Fine, sir. What else? Talking about the expression. How to find? How to find? Now in this, we need to take care. What if the object is moving in a straight line? That is quite simple. That is quite simple. If the body is moving in a straight line, that means the force and displacement both are moving along with each other. This is the direction of force. The displacement is also occurring in the same direction. That is okay. But what if the object is moving upward? By finding the component of displacement of the body in the direction of force, then what will happen in this case? Try to understand. Amazing question it is. So it says that there is an object, but the force is applied in this direction. Force is applied in this direction. Now the body is moving upward, finally reached at this point. So the displacement that you are going to observe, that will be how much? Sir, this is the total displacement. This is the total displacement. And because the force is in this direction, displacement is in this direction. Think about that. Force is in this direction. Displacement is in the upward direction. So I need to take a component of displacement that is going to be S cos theta. What will be the component of displacement? S cos theta in that case. Here it is written. Similarly, if force is applied in this direction, and this is the displacement, and if force is applied, so what exactly they did? Now the force is applied in this direction again, and we are considering this as displacement. Now force is here, displacement is again here. Again, what we have to do? Sir, component of force is required. So either you solve this way, or you solve in that manner. Ultimately, the work done value is coming out as force multiply displacement multiply cos theta for both the cases. Ultimately, we got to know what is work done, Fs cos theta. Sir, is it necessary to know more about cos theta? Or what if I am going to miss cos theta, then there will be a problem, bacha. Then there will be a huge problem. Sir, what kind of problem? Let me show you. What problem it will be. The types of work done will be explaining what kind of problem will be, coming in front of you. So the first type, that is positive work done. What it says? What exactly it is saying? If there is an object, force applied in this direction, and displacement, if you observe the displacement, that is also in this direction, in the same direction. So this is direction of force, this is also direction of displacement. Sir, this seems like parallel. What will be the angle between parallel line? Arey sir, quite easy. Angle between parallel line, that is going to be 0 degree. 0 degree, because they are not coinciding with each other, parallel to each other. Angle will be 0. So as per the formula of work done, that is going to be Fs cos theta or Fs cos 0 degree. The value of cos 0 is 1. That is coming out as work equal to force into displacement. and that too with a positive sign. There is no negative sign included. There is no negative sign included. Value of cos 0 degree, that is coming out as 1. Coming out as 1. So the finally positive work done will be W equal to Fs. W equal to Fs. Similarly, negative work done. Negative work done says if there is an object, you applied force from this direction but the displacement occurred in the opposite direction. Is this possible? Is this even possible? You are applying force in this direction but the displacement occurred in this direction. Yes, that can be happened. If you are fighting with your elder one and you are trying to pushing your elder brother and he is providing force, try to understand, you are providing force in this direction and he is pushing you back. So ultimately what you have seen, your direction or the application of force was in this direction but the displacement was in the opposite direction. Yes sir. So in that case what can be observed? Sir, force is in this direction, displacement is in this direction, and the angle between them, that is coming out as, sir, seems 180 degree. So theta is coming out as 180 degree and the value of cos 180 degree, always remember, that is -1. Value is -1. Okay sir. So in that case, if I need to write formula, W equal to Fs cos theta. Value of theta is 180 degree. Okay sir. So Fs cos 180 degree. Finally, the work done will be minus of Fs. Yes or no? Minus of Fs. This is why it is known as negative work done. In the previous, W equal to Fs, positive work done. Force and displacement same direction. Force and displacement opposite direction. Third one, zero work done. So zero work done was that na, where the displacement was not there. No, bacha. Not only that, there is also one more point that we need to take care. See, what if the force is applied in this direction and displacement occurred in this direction? So this is the direction of force, this is the direction of displacement. They are perpendicular to each other. They are perpendicular to each other. So theta is going to be 90 degree. And the value of cos 90 is 0. Yes. Now the work done is Fs cos 90 degree. Hence the work done is coming out as 0. Clear? Clear? Now over here, what will be the conditions and where you would be able to find this particular thing? So for example, I am having this object and I have kept it over my head. Where I have kept over my head. Now the weight or the force applied by the book will be in the downward direction. Of course, it is providing some force over the head. Yes sir, providing force, and I am moving in the forward direction. This is how porters and coolie do. They keep objects over the head and they are moving in the forward direction. They are doing zero work done. So then why we are paying them? Arey bacha, their mechanical work is done, some muscular work is done. For that we are paying. But in terms of physics, when we talk about how much work is done by the coolie to lift the object, in that case, what we say? There is zero work done. Clear? Perfect. Unit of work done, already explained, that is joules or represented by capital J. Talking about power. Before starting energy, power is required. So power is the rate of doing work. Rate of doing work. That is power equals to W by T. Rate of doing work. Work by time. In short, W by T. Unit is going to be joule per second. Also, unit is going to be watt. Unit is going to be watt. Capital W. Very good. Very good. Unit is going to be watt in that case. Now the point is, what if I need to solve some questions based on work done? Can we solve that? Let's give it a try. Let's give it a try. So there is one question, subjective question for now. Objective questions will be also there. A crane pulls up a car of mass 500 kg. to a vertical height of 4 meter. Calculate the work done by the crane. So there is an object. How much is the mass? Sir, mass is 500 kg. Mass is 500 kg and taken to a height of 4 meter. What will be the total work done? Anyone in the class can explain? Like what will be the value in that case? What will be the value of work done in this case? The mass is 500 kg, height is 4 kg, 4 meter. The value of G is 10 meter per second square approximately I have considered. The value of or the formula of work done that I have taken, that is Fs. Any problem in this? Force into displacement. Force into displacement. So force is mass into acceleration due to gravity multiplied by height. Mass is 500. G is 10. Height is 4. 20, 1, 2, 3. These many joules. These many joules. 20,000 joule will be the value. 20,000 joule, not 2,000. 20,000 joule will be there. That is going to be 500 multiplied by 10 multiplied by 4. Mass into acceleration due to gravity into height. Force is mass into acceleration due to gravity. Next question. Next question. A force of 10 Newton displaces a body by a distance of 2 meter at an angle 60 degree to its own direction. Find the amount of work done. So what is being given? The force is given. How much? 10 Newton. Displacement given 2 meter. Theta given 60 degree. What will be the work done? Can we apply formula directly? Can we apply formula directly? Yes. So work done, that is equal to Fs cos theta. Force is 10. Force is 10. Displacement is 2. And this is going to be cos 60 degree. Do you know value of cos 60? Cos 60. 1 by 2. 1 by 2. Very good. So 10 multiplied 2 multiply 1 by 2 cancelled. The value of work done is coming out as 10 joule. Good answer. Good answer. Perfect. Perfect. What else? Now the next point is energy, and that is going to be important for us. That is going to be really important. Why? Why it is important? Because there are certain segments that we need to understand in the energy criteria. So we will be discussing that. The energy of the body, yes, 10 joule. Perfect answer. So the energy of the body is the capacity of doing work. In a simple language, if I tell you, if I am moving my hand, this is the work done this is the work that I did for now, right? Only this much amount of energy has been consumed. Of course, if I am moving my hand from up, down, only that much amount of energy will be consumed, na? Or it will be like, I have moved my hand and all my energy drained. I'm tired. No, this is not going to be happen. So in a simple word, whatever work you do, only that much amount of energy will be consumed. Whatever work you are doing, only that much amount of energy will be consumed. This is why it says the energy of a body is the capacity of doing work, capacity to do work. And it is also a scalar quantity. Amazingly, its unit is also joule, one and the same thing. So whenever you are going to solve for work done, always remember whatever work you are doing, you are consuming the same amount of energy. You are also consuming the same value of energy. Correct? Units of energy, when we talk about that, so there are different kinds of energies. The one is watt hour, second one is kilowatt hour. Always remember that in the watt hour and kilowatt hour, there will be some relation that we need to take care. So watt hour, if I ask you what will be the value in kilojoule, will you be able to find out? Let me tell you that value is 3.6 kilojoule, by the way. 3.6 kilojoule. Whereas for the kilowatt hour, that is 3.6 megajoule. Your task is to find the value. Put the value and get the answer. Like you need to solve it for kilowatt. Like kilo will be 1000, watt will be joule per second, hours will be 3600 second. Multiply that. Right? Calorie and electron volt, another units. Please remember that. Difference between energy and power. It says that energy of a body is the capacity to do work, whereas power of a source is the rate at which energy is supplied by it. Right? So the one who is asking for the hard questions, like questions would be also appearing. PYQs are also there. Please be a part of this session. Energy spent does not depend on time, whereas in the power, power is dependent on time. Third one, SI unit is joule, SI unit is watt. These are the major differences that you can write even in the examination. Next, the types of energy. See, although there are so many types of energy that we come across, light energy, solar energy, heat energy, nuclear energy, wind energy, thermal power energy, so many energies are there. But in a mechanical energy, we will be discussing about potential energy. What energy we are going to discuss? Potential energy. And it says the energy possessed by a body by virtue of its change in position. So whenever you see there is a change in position, especially in height, in that case, or configuration of what? Configuration of a spring, if you are going to compress it, stretch it, if such kind of changes, if you see, the energy it is going to possess, that is going to be potential energy. And in that case, the formula that is going to be mgh. This will be the formula for potential energy. In most of the books, you would be able to see the representation of potential energy is given with U letter. U letter. So this is what potential energy is. Correct? Talking about forms of potential energy, there are even different forms of potential energy. Gravitational potential energy, second, elastic potential energy. So in gravitational potential energy, it clearly states that the potential energy possessed by the body due to the force of attraction of earth, due to the attraction of, due to the force of attraction of earth. In that case, the potential energy that I was writing, that will be completely applicable, that is mgh, because acceleration due to gravity we are using over here. Correct? Whereas in the in the next one, in the elastic potential energy, that will depend, how much is the displacement that we have seen, how much is the displacement that we have seen. So what kind of displacement? What kind of displacement? Initially there was a box. See, if there was a box which was kept over here, there is a box kept. Now what I'm going to do, I'm going to stretch it. So the position is going to be changed, and this would be like, now this is the change in position. This is the configuration changed. So this is how we would be able to find the value in that case. Formula would be like mgx in that case. mgx in that case. So that depends, the elastic potential energy, how we are going to solve this. Fine. Next, talking about kinetic energy. So in the kinetic energy, if the object is moving, think about, if the object is moving, which energy is there? Kinetic energy. The definition is quite simple. The energy possessed by the body by virtue of its motion, because there will be some velocity in it. There will be some velocity in that. So that will be written. That will be written as kinetic energy. Now to understand, I am telling you that the work is done, that is converted into kinetic energy. Would you mind if I'm going to write this? Would you mind if I'm going to write this? The point is quite simple. Sir, why you are writing all this? How you got to know? Like these all things are happening. My point was quite simple. I have taken one example where on the surface there was a ball. There was a ball. Initially it was at rest. Initially it was at rest. Okay. So the initially it was at rest, and finally it reached to v velocity. It is also having mass m, that will remain same. That will remain same. Now the force is applied, the body is moving, there is a velocity, there will be some displacement in between. Yes, sir. there will be some displacement. In that case, what we realize, sir, object is moving, there is a velocity, there is a displacement. In that case, there will be a kinetic energy. There will be a kinetic energy. Now, how to find this? So, I would say that if there is a work done happening in terms of kinetic energy, the formula is force into displacement. Yes or no? Yes or no? Now, formula. So, force is mass into acceleration. That is MAS. That can be written. So, mass into acceleration, I am writing it as it is. Whereas, talking about this value S, remember the equation of motion, the third equation of motion, if you can recall, what was that equation, bacha? What was that equation? Sir, V square minus U square divided by 2S equal to A or 2AS. Initially, it was like 2AS. So, what I'm going to do, I'm taking 2A in the downward or in the denominator, I'm taking the value of S. Taking the value of S, put it over here. That is going to be V square minus U square divided by 2A, A and A cancel, cancel. What I have got? Sir, mass into V square minus mass into U square divided by 2 divided by 2. Sir, but the initial velocity was 0. Okay. In that case, the kinetic energy is coming out as 1 by 2 mv square, or the favorite way of calling this, that is half mv square. What we call it as half mv square. This is how we are able to find the value of kinetic energy, and the formula of kinetic energy is finally in front of us, that is half mv square. Fine. Okay, sir. Relation between kinetic energy and momentum. If you know, so there is a formula called, or there is a term or quantity called momentum. What is that formula? Sir, mass into velocity. And what is the formula for kinetic energy that we have evaluated? So, momentum is mv, kinetic energy is half mv square. In case if any question, like if you see some question related to that, using this, so kinetic energy is equal to half mv square. I'm just giving you a trick how to solve. Multiply. So that is going to be 2 times kinetic energy, that is equal to mv square. Multiply m on both sides. So that is going to be m square v square. I'm just writing like mv whole square. See, m square v square can be written as mv whole square. That is 2 times m kinetic energy. This is momentum. So P square, that is equal to 2m kinetic energy, and finally momentum is equal to 2m kinetic energy. This is the relation that you can remember. If any question based on that, if you find, or by cross multiplication, I can write kinetic energy equal to P square by 2m. P square by 2m. This can also be written here. Momentum equal to under root 2m kinetic energy. Kinetic energy equal to momentum square by 2m. So that depends which value been given. If kinetic energy given, use this formula to find momentum. If momentum is given, use this formula to find the value of kinetic energy. Fine. Now there is one question right in front of you. A body of mass 5 kg, body of mass 5 kg is taken from a height 5 meter to 10 meter. Find the increase in its potential energy if the value of G is 10 meter per second square. I am just trying to give you like 45 seconds to solve this question. Everyone, please give it a try. Options are there. Simultaneously, if you want, like, I'm also going to solve along with you. It says mass is 5 kg. Height is going to be, the total height is 10 minus 5, that is 5 meter. Why? Because it was taken from 5 meter to 10 meter. So height is going to be 5 meter. Value of G is given as 10 meter per second square. Finally, if I need to calculate the value of potential energy, that is going to be mg. H mass is 5, G value is 10, height is 5, that means 250 joule will be the value of potential energy. As a result, option number B is correct. Option number B is right. Similarly, next question, a body of mass 1 kg falls from a height of 5 meter. How much energy does it possess at that instant if the value of G is 9.8? So what has been given to us? Some mass, that is 1 kg. Height given as 5 meter. Value of G 9.8. And we need to calculate the value of potential energy. That is going to be mgh. So U equal to 1 multiply 9.8 multiply 5. How much it will be? 49, 49, 49. Yes. So that is coming out as 49 joule. That is option number A. Done. Fine. So there is one more interesting question over here. A truck driver loads some oil drum into a truck by lifting them directly. Each drum has a mass 80 kg and a platform of the truck. I see this question is from like a different question, and I want you to solve this. So I'm giving you as a homework. Please give it a try. That is an interesting question. Please read that later and try to solve. Okay. Now one more question. Calculate the kinetic energy of the body of mass 2 kg moving with a speed of 10 meter per second. So how to solve or proceed? So mass given as 2 kg, velocity given as 10 meter per second. Now the kinetic energy given as half m v square. So 1 by 2, mass is 2, velocity that is coming out as 100. Finally, the kinetic energy value is nothing but 100 joules. Done, sir. Option A. Clear? Next question. How fast should a man weighing 600 Newton run so that the kinetic energy is 750 joule? Now in this question, they are not providing mass. They are given weight of the object. That means what is being provided? Sir, the force is given, that is 600 Newton, and kinetic energy given, that is 750 joule. And the value of G is given 10 meter per second square. And we need to find velocity. Now the point is how to find mass. How to find mass? So I am going to use F equal to mg. Force is given as 600. Mass is unknown. The value of G given as 10. So the mass is coming out as how much? The 600 by 10, that is 60 kg. 60 kg. I think from now onwards, kinetic energy, or to find the value of kinetic energy, that is going to be easy for everyone. That is kinetic energy, that is going to be half mv square. Mass is so 60. Velocity unknown, velocity square divided by 2, and kinetic energy value is 750. So this is going 30 times. V square is 750 divided by 30, 0, 0. This is going to 5. And finally, the velocity is coming out as 5 meter per second. Option number C is correct. This is how we solve, because whatever values been given, we are going to proceed according to that. Next question. For the same kinetic energy of the body, what should be the change in its velocity if its mass is increased 4 times? Over here, what is given? So there are two bodies or of the different masses. one of the body carrying mass m, another body carrying mass 4m, but they have same kinetic energy. So in that case, it is being given that the kinetic energy of the first body is equal to kinetic energy of the second body. But the amazing fact is, like 1 by 2 mass velocity square, that is 1 by 2, 4 times the mass. This is what they are saying. Mass is increased 4 times. So for the same, what should be the change in velocity they are asking? That is going to be v square. Correct? Correct? Any problem? Any problem with that? So velocities will be different as well. Velocities will also be different, right? So just naming it as v dash. From here, like 1 by 2 cancelled, m cancel. So I will be getting v square is equal to, or v dash square equal to v square by 4. Right or wrong? Clear na? What should be the change in velocity? This is what we need to see. And from here, v dash is coming out as v by 2. V by 2. So what should be the change in velocity? Half. That is going to be half. Done. These kind of questions that you can give it a try. Yes. Now the important part is work energy theorem. What is work energy theorem? See, this theorem is actually helping us to solve, or providing us providing facility where we can solve any question related to this, related where the work is done or some energy is being utilized. We can directly use work energy theorem in that case. And the work energy theorem, it says the work done by the force on a moving body is equal to the change in, not increase in, it would be like change in kinetic energy. Change in kinetic energy. Change in kinetic energy. Fine. So directly if I need to write, that is going to be W equal to, directly I can write it as work equals to change in kinetic energy, or the statement is work done is equal to half mv square minus half m u square. See, we derived the formula for the kinetic energy. In that case, the value of initial velocity was 0. Here the value of initial velocity is not going to be 0. Value of initial velocity is not going to be 0, where half mv square is nothing but final kinetic energy, and half mu square is going to be initial kinetic energy. Initial kinetic energy. This is how we are going to write, or W equal to, work is equal to kinetic energy final minus kinetic energy initial. See, these are the ways by which, or by, these are the methods through which you can write those values. So work done is equal to final kinetic energy minus initial kinetic energy. Work done is equal to half mv square minus half mu square. This is what you can write. Talking about translational kinetic energy, now there would be some direct things that you should know. The kinetic energy of a body, the kinetic energy of a body due to motion in a straight line, that will be translational. Rotational, due to the rotational motion, whatever kinetic energy is going to be there, that will be known as rotational kinetic energy. Similarly, vibrational kinetic energy, if the body is vibrating, in that case, that is going to be vibrational kinetic energy. Yes, yes, complete syllabus. Talking about the difference, most common question being asked, potential energy, kinetic energy. In that case, it is the energy possessed by the body due to change its position or configuration, and this is due to the motion. Second, it is equal to the work done bringing the body to its changed state, whereas before coming to rest. Kinetic energy is the equal to the work that moving before coming to rest. Third, it can change only in the form of kinetic energy. It can change in any other form. Last, it does not depend on the speed of the body. It is depending on the speed of the body. These are the common differences. Common differences. And frequently asked question. Correct? What next? Energy and power. So energy of a body is its capacity. I think we have already done that. Next is talking about conversion of potential energy into kinetic energy. Conversion of potential energy into kinetic energy. Like most of the students are confused, like how they are going to be confused, like how they are going to convert, right? Or how is this possible even? How is even this possible? So the answer is quite simple. If there is a big stone falling like that, there is a stone falling on the wooden block, there is an iron nail and that dropped down the nail, what is going to be happen? What is going to be happen? Sir, iron nail will penetrate into the wooden block. Right, this is going to be happen. So what exactly has happened, sir? When the object or the stone was dropped from height, it was possessing potential energy, but while moving in the air, it possessed kinetic energy. What energy it possessed? Kinetic energy. Similarly, look at this boy. The potential energy by pulling this bow arrow combination, the because of this elastic motion of this particular wire, the arrow was stressed, potential energy generated, and when released, the arrow moved in the forward direction with a very high speed. That is kinetic energy. That means the potential energy can be converted into kinetic energy. Okay, bacha? Even in this, the old time that key watches, spring bean to state to state to state. Later on, it was slowly moving with the watches, and this is what happened. Spring unwinding happened. That is called potential energy converted into kinetic energy. This game everyone must have played somewhere. Press it down, release it, toing, the ball will move. Correct, correct. Talking about solar energy, now there will be the different forms of solar energy. Solar energy provided by the sun, of course, and there will be a solar panel that will be used for the various purposes, especially for the electricity generation these days, and this is what we are doing. Heat energy, the heat energy or the energy released by the burning coal, oil, wood or gas, that is heat energy. Next, light energy provided by the torch or any other source, tube light, LED, right? Chemical energy, energy possessed by the fossil fuels such as coal, petroleum, natural gas, that is called chemical energy. There is one more example, photosynthesis process. Process of photosynthesis is also a chemical process. What else? Hydro energy, dam. Dam, we have seen the energy possessed by the how fast moving water, that is called hydro energy. Then we have electrical energy, nuclear energy, nuclear fusion, nuclear fission, that is going to be happen. So these are the energies that we generally know, apart from potential and kinetic energy. What else? Geothermal energy, the energy, the heat energy possessed inside the earth. Inside the earth. So there will be a hotspot where some heat is going to be generated. That is called geothermal energy. Then we have wind energy, windmills being used, sound energy, vibration of the bodies will create sound energy. So these are the different forms of energies that you should be familiar with. These are the examples, like this is heat from the earth that is used to generate electricity, geothermal, like that, windmills, sound energy. So these are the examples. Magnetic energy, when two magnets are coming in contact, maybe they are going to attract or they are going to repel. Then mechanical energy, finally. Mechanical energy is the combination of potential energy and kinetic energy. Mechanical energy is a combination of potential energy and kinetic energy. So energy possessed by the body due to its state of rest or motion, that is called mechanical energy. So in short, I am going to write mechanical energy, that is equal to potential energy plus kinetic energy. Perfect. Okay. So these are the examples that we have seen. Now, they are interchangeably, they are interchangeable. Energies are converting from one form to another, like mechanical energy to electrical, electrical to heat energy. So examples, electric iron, electric energy to sound energy, loudspeaker, electric energy to chemical energy, charging battery, chemical energy to light energy, lighted candle, electric energy to light energy. See, these are the common examples that we have seen n number of times since childhood. Correct? Talking about conversion. So mechanical energy to electrical energy, this is what I told you, electrical to mechanical, electrical to heat, heat energy to electrical energy. So this is how we can convert the various forms of energy into the other. My question is over here is, the body at a height possesses which kind of energy? If I give you like 30 seconds to answer this question, would you be able to answer it? Please tell me. Or in the comment section, you can tell me. Like, a body at height possesses which energy? Kinetic, potential, solar, or heat? 1, 2, 3, 4, 5. It is going to be potential energy. Correct? Correct. Good answer. Good answer. What else? In an electric cell, while in use, the change in energy is in the form of what is there in the cell? Sir, chemicals are there. Chemicals are there. Right. Chemical converted to electrical. Yes, sir. Electric bulb generated. Conservation of energy. Let me conserve my energy. Okay. Just give me a second. Chemical to electrical. That is right. Right. Absolutely right. So in the conservation of energy, in that according to the principle of conservation of energy, energy can neither be created nor be destroyed. Fine. The concept is quite simple. Energy can neither be created nor be destroyed, but it can be transformed from one form to another. Tanishk is asking, sir, why are you? See, today they are not watching, but later on they would be able to watch, na? At least they would be having a complete set of syllabus. This is why I'm doing it. So if you want to be a part of it, wonderful. If no, that is okay. Fine, come over here. So my point is, so over here, if I need to see what is going to be happen if the ball is being thrown upward from the ground, and I'm considering there are 3 points. There are 3 points that I'm going to consider: position A, position B, position C. So this is A, position B, position C. This is height h. This is height h. Correct? Total height h. Ball is thrown upward, or the ball from the top, it is going to fall down. The mass of the ball is m. Initial velocity is u, the final velocity, that is v, and intermediate velocity that I am considering, that is v dash. V dash. And this is the distance it traveled in moving from position A to B, that is distance x. Fine. This is what we have seen. Now in that case, if I need to find the value of energies over here, so at position A, can you please tell me what will be the potential energy? Sir, there is a height h. Only there is one energy that is going to possess, that is called mgh. mgh. Second, if I ask you, will there be any kinetic energy? No, sir, it is placed over here. It is placed over here. There is a no velocity. That means that is going to be 0. So in that case, mechanical energy, that is potential plus kinetic energy, that is going to be 0. So mechanical energy is going to be mgh at position A. mgh at position A. That is the very first thing. Talking about if the object is moving from A to B, intermediate. This is the final C position, intermediate. In that case, what will happen? At B, will there be any potential energy? Yes, sir, there will be a potential energy. mg x, no, it will be h minus x. H minus x from the ground. That is going to be h minus x, and that will be written as mgh minus mgx, potential energy. Yes or no? Yes or no? But if I ask you, will there be any kinetic energy? Any kinetic energy? So, kinetic energy, that is going to be half mv dash square. Half mv dash square. And we know equation of motion. What is the equation of motion? Sir, v square minus u square, that is equal to 2gs. That is the equation of motion. But the initial velocity is 0. So that is going to be v dash square minus 0, that is equal to 2gx. Let's put the value of v dash square in the above equation. What we are going to get? Sir, we will be getting kinetic energy as 1 by 2 mass multiply 2gx. 2 and 2 cancelled. Kinetic energy at point B. Kinetic energy at point B, that is going to be mgx. Talking about mechanical energy. Mechanical energy, that is going to be sum of potential plus kinetic energy. Potential is how much? Sir, mgh minus mgx. mgh minus mgx plus mgx cancelled. Finally, the mechanical energy even at position B, that is coming out as mgh. Yes or no? Third, at position C, we are going to do the same, and over here, that is coming out as potential energy at point C, that will be 0 because there is no height. Whereas the kinetic energy at point C, that is going to be half m v square, and again I am going to use the same formula, so it will be giving us half. Velocity will be coming out as how much? Sir, 2gh. Why? Because now the displacement is complete h. So the kinetic energy at point C, that is mgh, and overall observation that we have got from here, that is mechanical energy at point A is equal to mechanical energy at point B, and that is equal to mechanical energy at point C. Mechanical energy will remain same at all the point, even if it is moving from A position to B or B to C. At every point, it is going to be mgh. Fine. Motion of a simple pendulum. See, there is one more concept that is related to the motion of the simple pendulum. In that, we need to find the value of the simple pendulum, how this is going to work. And amazingly, if the momentum is going to move from one position to another, if the momentum is going to move from one position to another, correct? So this is going to the extreme positions. This is going to the extreme positions. That means it will possess potential energy at this point. It will also possess potential energy at this point. But at this point, potential energy is going to be zero. There will be a kinetic energy, some kinetic energy. What will be the value? Exact same thing is going to happen. That means the mechanical energy that you are going to obtain, the value will be coming out as mgh. The same amount of value that you will be obtain, mgh, for the mechanical energy. No matter whether you are solving for the ball or you are solving for simple pendulum, the values will remain same, right? Next is, there is one question over here and it says a crane pulls up a car of mass 500 kg to a vertical height of 4 meter. Calculate the work done by the crane. Now how to solve? This is being given. So the mass is given as 500 kg, height is given as 4 meter. We have to calculate value of work done. Can I apply the formula for the potential energy? Same formula. So the potential energy or the work done, that is mgh. Put the value, that is 5000 or 500 multiply 10 multiply height is 4. That is coming out as how much? 5000 into 4, 20,000 joules. Option number D is correct. Option number D is correct. Second, force of 10 Newton displaces a body by a distance of 2 meter at an angle. I think we had done the similar kind of question, right? So as a summary, when we got to know about like conservation of energy, we got to know about the different energies, that is potential, kinetic, and the conservation or the conversion of energies. We have completed our energy part till here, including power. There are some questions that you also need to try based on that. So today, the summary says we have covered our force portion, then we completed our work, energy, and power. This is what been completed, but this chapter is not completed, that we know, because there are certain other elements that is left, that is simple machines, so lever, pulley, combination of pulleys, so that we are going to cover in our part 2. So this was all in part 1, and the second part will be covered very soon, where we will be taking the rest of the lectures. For today, thank you so much. And homework, the questions that I gave you.